Hello, and this is Mrs. Edwards. We're going to do the review and preview problems 7-140 to 7-146 in the CCG book. 7-140. Each problem below gives the endpoints of a segment. Find the coordinates of the midpoint of the segment. If you need help, consult the math notes box from this lesson. So when we're looking at the ordered pair 5, 2 and the ordered pair 11, 14, if we had these plotted on a coordinate plane, we could visualize a little bit better where the center of these 2 points are. We're still going to find the center of the 2 points the exact same way as if we had 5 and 11 plotted on a number line. To find where these two intersect, we could use our jumps and tell that they intersect right in the middle at 8. We can also take 5, add it to 11, and halfway between 5 plus 11 is 8. We can then find the y-coordinate of our ordered pair, or where this will be on the coordinate plane, by doing the same thing. 2 plus 14 divided by 2, 16 divided by 2 is 8. Looking at B, if we take 3 plus 10, divide that by 2, we get 6.5. 8 plus 4 divided by 2, 12 divided by 4, 12 divided by 2 is 6. So the ordered pair, be really careful. We want to make sure that our x comes first, 6.5, and our y-coordinate comes second. 7-141. Below are the coordinates of 3 points and the equations of 2 lines. For each line, determine which of the points, if any, lies on that line. So remember, these are coordinates, are ordered pairs, so they represent an x and a y value. So in order for the ordered pair to be a point on the line, when we plug the ordered pair in for the x and the y, we should then get a true statement. So if we start with letter A and we plug our y-coordinate in for y, our x-coordinate in for x, and solve, 1/3 times 0 is 0, plus 15 is 15. We got a true statement, so we can say that x is an ordered pair for the line y equals 1/3 x plus 15. We then can try the next ordered pair for the point y and see if y is also on that line. So we're going to replace our y value with our y. We're going to replace our x value with our x. We multiply fractions straight across, so 3 over 3 reduces to 1. 1 plus 15 absolutely gives us a true statement, so we can also say that y is also a coordinate on that line. When we test to see if z is a coordinate, we're going to replace our y with our y value, replace our x with our x value, multiply straight across, 7/3 plus 15, and we notice that 0 is not equal to 7/3 plus 15. So z is not on the first line. Then we're going to do the same thing for equation B. If we replace our y value with what they told us our y equals, replace our x value with what x is in the ordered pair, we follow our order of operations. 15 minus 16 is -1. When I distribute a -4 times 0, I get 0. -4 times -3 gives me a -12. -1 absolutely does not equal -12. So x is not on the line. So we're then going to try coordinate y. So we replace our y with 16, our x with 3. 0 is equal to negative 4 times 0. 0 is absolutely equal to 0, so y, or the ordered pair 3, 16, is on the line. Y minus 16 equals negative 4 times the quantity of x minus 3. Let's take a look at z. 0 minus 16 is equal to negative 4 times 7 minus 3. Negative 16 is equal to negative 4 times 4 is negative 16. Z is also a point on line B. 7-142 must be, could be. Here are some more challenges from Mr. Quincy. For each description of a quadrilateral below, say what special type of quadrilateral must be, or what special type of quadrilateral could be. Look out, some descriptions may have no must be statements, and some descriptions may have many could be statements. My quadrilateral has 2 right angles. Well, I can think of several things that it could be. Something with 2 right angles could be, but is not limited to, a square. Could also be a rectangle. And it could also be a right trapezoid. But when we say it must be, the definition, or having 2 right angles, does not define any specific quadrilateral, so we would say none. Looking at B, the diagonals of my quadrilateral are perpendicular. So if we are talking about a 4-sided figure and our diagonals being perpendicular, I can think of a couple things that it could be. The diagonals are perpendicular on a square. The diagonals are also perpendicular on a rhombus, as well as a kite. However, there is no quadrilateral that just by having perpendicular diagonals defines the quadrilateral, so there are none that it must be. 7-143, examine the arrow diagram below. The diagram says polygon is a parallelogram, which yields the area of a polygon equals the base times the height. The first thing in letter A it asks us to do is write this conjecture as a conditional or an if-then statement. So we can say if a polygon is a parallelogram, then its area equals its base times its height. Write the converse of this conditional statement. Is the converse statement true? So if the area of a polygon is the base times the height, then the polygon is a parallelogram. So looking at this converse statement, we can absolutely say that yes, this is always true. Moving on to letter C, it says write a similar conjecture about triangles. Write it once as a conditional statement and once as a arrow diagram. So we can say if a polygon is a triangle, then its area equals 1/2 base times height. To write it using an arrow diagram, we would simply say a polygon is a triangle, which implies the area of the polygon equals 1/2 base times height. Write the converse of our triangle conjecture. Is the converse statement true? So we then say if a polygon's area is 1/2 base times height, then the polygon is a triangle. And we also can conclude that this statement is always true. Seven 144. The angle created by a hinged mirror when forming a regular polygon is called a central angle. For example, if we look at the polygon below, angle ABC in the diagram is the central angle of the regular hexagon. If the central angle of a regular polygon, so let's say this angle measures 18 degrees, how many sides does the polygon have? So a polygon is 360 degrees, so we divide that by 18 and we would get 20 sides. So the polygon would be a 20-sided figure. Can a central angle measure 90 degrees, 180 degrees, or 13 degrees? Well, when we look at a polygon and we take 360 degrees and divide it by 90 degrees, we would get 4, which would give us a square. If we look at 180 degrees and we take 360 and divide by 180 degrees, this polygon would only have 2 sides, which no matter how we have 2 sides, they could not connect. So we would say that it cannot be the central angle can't be 180 degrees because it wouldn't form a polygon. When we look at 13 degrees, if we take 360 and divide it by 13 degrees, this does not divide evenly. So we couldn't have a side that is a decimal. So we would say it cannot be 13 degrees either. Seven 145. Jamaica designed a game that allows some people to win money and others to lose money, but overall, Jamaica will neither win nor lose money. Each player will spin the spinner below and will win the amount of money shown in the result. How much should each player pay to spin the spinner? Explain your reasoning. So here is where we want to reference back to expected values. And when we find the expected value, remember we take the probability of that section of the circle. So the probability of spinning a $3 is a 1 out of 4 chance. So we take that 1/4 and we multiply that by the dollar amount in that section. The probability of earning $1 or spinning $1 is a 3/4 chance. So we are going to take 1/4 times 3 and add that to 3/4 of a chance of spinning $1, and we get $1.50 per spin. So each player should pay $1.50 so that there is no net gain or loss over many games. So spinning $1.50 per person would mean that there are no net gains or losses over many games. Suppose that ADBC is a quadrilateral and the diagonal AB lies on the line y equals -4/3x plus 5, and diagonal CD lies on the line. So I'm just going to sketch y equals -4/3 x plus 5, and the other diagonal lies on the line 3/4 x minus 1. Assume that the diagonals intersect at point E. Without graphing, what is the relationship between the diagonals? How do you know? So looking at the slopes for both of these equations, my diagonal AB, the slope is -4/3, and my diagonal CD, my slope is 3/4. So I recognize that my slopes are perpendicular. And I know that because they are opposite reciprocals of one another. Part B says graph the lines on graph paper. If E is the midpoint of CD, what type of quadrilateral could ADBC be? Is there more than one possible type? So if we graph line CD, we are going to start at -1 on our y-intercept. We are going to go up 3/4, up 3/4. Then we are going to graph line AB. So we start at 5, and this time we are going down 4/3, down 4/3, and looking at these, we can make a couple of different observations. So we know that our lines our midpoint is perpendicular based on our slopes. So if our lines are the same length, this could be a square because the diagonals are perpendicular. And when they said it is a midpoint, we know that one diagonal bisects the other diagonal, making them equal. It could also be a rhombus, because the diagonals of a rhombus are perpendicular. And it could also be a kite. So it could be any of these three things based upon the fact that the diagonals are perpendicular and at least one diagonal is bisected. So we know that one of these lines is cut into half.